All right, we're working on probability, and I'm hoping you read the chapter because I am definitely skipping some of the simpler probability ideas, like how many events are there if you flip a coin, or how many events are there if you flip 2 coins. Use the book if you're confused about those. But what I wanted to focus on is some of the probability that the book does not have in it. Some it's there, some it's not. But we start out with a quiz question that looks an awful lot like this. They tell us that A and B are independent events, and they give us the probability of A and B, and then they ask us to find A and B. So pay attention, because I'm going to write down the formula that was not always obvious in the book, because you'll need the formulas in order to do this correctly on the quiz. So if we have independent events, the probability of A and the probability of B happening is just we multiply our 2 probabilities together. So they give us the probability. Our probability of both A and B happening is going to be 1/4 times 2/3. And you don't have to reduce the fractions you put in the quiz, but I like them reduced because they're just easier to type. So that's 1/6. The probability of A or B happening is we add the probability, so it's the probability of A plus the probability of B. So this is the or. But we also subtract the probability of both A and B happening. Now, we just calculated that number in the previous step. So, and I'm going to run out of room here. Let's see if I can fit this in. We get 1/4 plus 2/3 minus 1/6, the probability we got from the probability of A and B. So I'm going to convert all of these to 12ths. And this is a little messy, I know. So I get 3 12ths plus 8 12ths minus 2 12ths. And that looks like it's going to be 6 plus 3, 9 12ths. Or 3 goes into 9, 3 times 3/4. Either. Again, you don't have to reduce the fractions. You do have to add or subtract. It'll only accept one fraction. Okay, the probability of A not happening, probability of not A, is 1 minus the probability of A. And the probability of A is 1/4. 1 minus 1/4 is 3/4. The probability of not A and B. All right, this is another, well, okay, so what we're going to do is just take 1 minus the probability of A and B. And again, we calculated that in the first step above. So it's 1 minus 1/6, or 6/6 minus 1/6, 5/6. All right, enough of that. On to some, now I'm not sure how much of these needed to be covered. I'm covering the cards because, you know, cards, I don't know if you know how they work. But let's look at this one. You roll a 6-sided die, find the probability of rolling a 4 given you roll an even number. So probability we roll a 4 given the number we rolled was even. Well, if you look at a die, 3 out of the 6 numbers on the die are even, and 4 is also an even number, so we get 1 out of 3, and that's fully reduced. So on this one, now we do have formulas for finding something out given, but often you just use some common sense to figure these out. All right, so a regular card deck, given the probability, you draw the following. By the way, a regular card deck has 4 suits with 13 cards each. And out of those 13 cards, 3 are what we call face cards. 13 cards each, 3 face cards, which means you have 10 number cards. Okay, so the probability of drawing a spade. Well, look, a spade is 1/4 of the deck. You could look at it as 13 divided by 52, but that's just 1/4. So there's 13 spades out of the 52 cards. Oh, by the way, there are 52 cards in a deck. Okay, probably drawing a 9. Well, each suit has a 9 in it, so there's 4 suits. So we get 4 out of 52. That'll reduce to 1 out of 13. And the probability that we draw a face card. Well, there are 3 face cards and 4 suits. So 3 times 4 is 12. There's 12 face cards in the deck. So the probability of drawing a face card is 12 out of 52. And that will reduce to 3 out of 13. Okay, I'm going to stop this video. I'll see you on the next one.